Okay, good evening, Diane and Norlins. Today we are continue about our courses in financial technology and data analytics. In this lesson, we will continue about the materials for data analytics with the new subsections, which is the name of inference. Last week, we learned about the data descriptions with Norlin, okay? And the material is sent to your emails with the Excel files for the self exercise. Before I start, I'd like to know about how good your exercise about to creating a chart or maybe a table. Do you have any difficulties creating a bar chart, maybe a pie chart and the pivot tables?
For me, sir, it was not that hard since the
Mhm.
data were already given.
Yeah.
So it was easy to just insert charts or any graph.
Okay. Thank you. How about you, Norlin?
For me, sir, it
Mhm.
since it was familiar, we already done that in our school, so it was not hard for me.
Okay, creating a chart, creating a table is the basic starting for our data analytics in every condition. So if you can creating a chart and table, it means that as a simple data analytics, you can make some examination with the data. And today we are going to the new levels of your data statistic in the advanced level about the inference. The inference, we will start with the samples. The sample is a part of the population. As we learned before, that the population is a set of all the members with the data. So all of the data is called the populations. When there is a sum of characteristic and where is the different characters, the different treatment, and the combination of all the variables. And with this data or with these populations, we need to make a little bit of the subset with the populations. We call the sample. To gather samples, we need a sampling techniques. What is the mean of the sampling techniques? We need to a piece of the populations to be examined, to be observed in a small observations rule or in the small frame. We call a sampling units to creating a sampling from the populations. Let's say the population is 1 million and we need to only 100 of samples. We need one of 10 the populations. We have the two kinds of creating about the sampling units using the probability or using the judgment sampling. The judgment is depend on our judgment. You have the rules about to creating some samples, but the probability sampling is different. You can make a random mechanisms using the percentage or using the occurrence with the statistical methods to making a probability sample. That's the difference between the probability sample and the judgment sample. The familiar of sampling methods we called about the random sampling. This is the cheaper or the easier methods where we are gathering a sample for populations. Why the random sample is the best or is the easiest way to creating a sample? Because we only make a simple mechanisms. You only select with no preferences, with no criteria. Just pick samples from your populations. That is the random sample. The simple random sampling is the simplest type of sampling. It's, you know, that the random is very easy. That is a simple random because you only take a piece of your populations with a smaller size. Like this one, maybe you have lots of uh, examination scores, but today we only take one course or one exams. So that is simple random samplings. That is, the possibility of simple random sampling is equals, or you can say that we have the same probability between the sample 1, sample 2, and the other samples. The simple random sampling is having the chance positions, or we have the chance of the probability between another samples, and sometimes we call this is an invisibles, because we know the number, we know the amount of the populations. In Excel functions or Microsoft Excel functions, you can create a random sampling using this formula ran, or maybe ran between. So let's say that we have a 40 observations in here, and you can choose with the random sampling with the number family number 1, number 2, number 12, number 7, and the others. So the computer or the software will pick a random number for you. There's no considerations between choosing a sample in your populations. Just using about the ran or ran between in your Excels. Let me make some exercise for you. Okay, I changed the share screens. Okay. Let's see that we have in the third of our data, baseball salaries. We have the number of center field design hitter here. We learn about the salary about the baseball player. So if you find about the random like this one, you can use with the formula ran or ran between. Let's say that we have a ran between. That with ran between, you need to create pick a number with the smallest of a salary. Let's say we talk about 1,000, between 1,000 into the 6 million. So the software will choose you about this number, 4 million. It is separate in this data. It's located in this data. So the random sampling, we are using the random function in Excel. We're considering about our data with the bottom value and the top value, and the software will be search about the random number between your range, from the bottom to your upper value. Next to the systematic sampling. The systematic sampling is rather bit different with the random sampling. When random sampling is without considerations, but the systematic sampling is with the consideration. That is the difference between random sampling and systematic samplings. In kind of systematic samplings, you need to create some block or some layers. That is, maybe with the first layer, you pick a sample from the first layer. And then for the second layer, you pick another samples. So there is no occurrence between the sample number 1 and sample number 2. There is a different concept between the random sampling and systematic sampling. In the systematic sampling, we have a kind of the stratified sampling, or we have the different stratifications, like the first stratification, the second stratifications, and another stratifications. And in the different class of stratifications, maybe we can choose with a random sampling. The another portion of systematic sampling is called the proportional sample size. You can create you can take a samples from the proportion. Maybe you can choose with the first 10% of proportions, and then you can choose with the next 50% of your proportions to creating a samples. So there is, with the calculations, with the step, with the considerations, we call it about the systematic sampling. I hope you learn, you know about the difference between the random and the systematic. Yeah. The another class of the systematic sampling is a cluster samplings, but the concept is similar. You need to make a different cluster. The first cluster, the second cluster. Between the cluster, you pick a samples. So you need to create some populations. It's a cluster one, cluster two, and between the cluster you pick a samples. Let's see about the cities or countries. You have the different cluster, or maybe with the local governance, and you pick a random sample from the different cluster. It's still systematic samplings. And then we also have the multi-stage samples. In your university, maybe you need to learn about the multi-stage of samples. Sometimes the lecture having the different considerations to creating a samples between the freshmen and the senior students to creating a responding or about maybe the group of survey with the first year of student, the second year of student, and the third year of student is they have the difference survey. That is the multi-stage of sample. Okay. The next, from the after the sample, we need to learn about the estimations. The estimation is talk about the proportions or the probability that we can take from the samples to be observed from our sampling methods. This is a little bit more complex than our definitions about the random sampling and systematic sampling, because the estimation is talk about the error or the estimation of error. If we pick a samples, we are not purely or originally is a good samples. Sometimes we pick a bad samples, or maybe it's containing a bad sample. So we need to estimate about what kind of our error, what kind of our mistakes. So in the social methods or in the social science, we have the three kinds of difference estimation error, or we can learn about the confidence interval later. Like we have, maybe we estimate about 1% of error, 10% of error, or maybe 5% of error. It's like this. If you estimate you have 1% of error, you believe or you trust your data is 99% of the corrections. So that is the 100 minus the error. If you feel that you have a 5% of error in the data, you only believe your data is on containing 95% of the corrections. So that is the sampling error, or maybe the bias of error. So the error, it could be happen with the responding bias by your survey, or maybe with non-truthful response. Maybe you can have a questionnaires, but the respondent is not particularly respondent. I think like this, like if I have a survey with the senior students, they could be inevitables with the freshman students or the newcomer of the students. That is the non-truthful of response. Sometimes the source of estimation error is come from the response bias, when the respondent or the potential respondent respecting your response or your survey, but they have some considerations or some reflections that could be make a poor or bad estimations, or the bad decisions that could be cannot be measured, or maybe cannot be a good survey instrument. So to cover the estimation of error, we need to learn about the distribution of the mean samples, or we call about the mean error. As we learned before, we need to know about the average of the data. We call or we calculate about the mean or the average, right? And to consider about our error of data or the estimation of error, we need to calculate about the mean error, or we call in the statistical methods, we call the standard deviation. That is considering about the average, and we also considering about our estimation error. That is the combination of standard deviation. So the standard deviation or the mean of error could happen if we have a finite population. What is the finite population? It's similar with the countable populations. So make sure that if you have a population, it should be countable. If your population is uncountable, you cannot make a mean error or the standard deviations. Let's say that you make a survey with the Philippine people. That is the finite populations. You can find the number of population in Philippines. Okay, but if you talk about the population all of people in the world, that is infinite population or uncountable in populations, because we don't have the data all of the people in the world. Sometimes there is a big bias or big error over there. Okay, there is the difference between the finite and infinite populations. The finite population or countable populations is the considering way to creating about the number of your populations. We learn about the big N in here. Let's say that okay, this one, the big N is for populations, and the small n is for the samples. So the finite population correction is talking about the range between the big number of your samples, we call it populations, minus with the sample of your data or the number of your populations, the number of your samples. The consideration of mean error is under the central limit theory. The central limit theory is talking about the normal of distributions. What is the normal distribution? The normal distribution is take the action that your data is randomly and also distribute with the bell shapes with the similar or equal proportion below the average and over the average. So if you can make the separation of data like here, maybe we have the bell shape like here, there is the any different the proportions between, this is the X bar or the mean, the proportion over the mean and the proportion below the mean is equal or similar. That is not exactly similar, but it's almost similar or closely similar. That is the basic assumption in the central limit theory. But in the central limit theory, it could be different in any option of the size sample. When we think about the size of sample or the size of the populations, we need to thinking about the criteria, like what cause it could be happen, or it's timely or not, or maybe how big the chance of your error should be considered, because the sample size is not easy ones. You need to make a planning stage, and maybe to be you have a tendency to minimize about your error of data. Okay, sorry. Let's continue about talking about the confidence interval of estimations. If you learn about the error of data, we need to learn about the confidence of intervals. In the previous materials, we learn about the estimation of error. Let's say that if you have 1% of error, 1% of error, it means you need you have a 99% of confidence intervals. If you have 5% of error, it means that you have 95% of your confidence. It's similar to the 10% of your error, you also have 90% of the confidence. So that is the basic concept of the confidence intervals. It's between the 100%, it's containing with your confidence and your error. We use it for creating about the probability or maybe with the function of the predictions. In statistical or in the data analytics, we call about the distributions. It could be a Z distribution or T distributions. If your sample is small, you can use the T distributions, but if sample is big, you can learn with the Z distributions. But it's the same. It's the difference is only for the notations, for the big size or the small size. The T distribution is talking about the sample of the sample of measurements, but the population we call about the Z distributions. Look at the distribution of this T table. It could be a bell shape like the normal distributions, and it's containing the similar or the reflection of the data between the average over the average and below the average, over the mean and upper the mean and below the mean. For the sample that we doesn't know about the number of populations, or we call infinites or uncountables, we can use about the chi-square or F distributions. I think you need to make new deepen of materials using the chi-square or the F distribution in your basic of statistics, not in here, but this is the concept of data analytics. If you find a population or sample is uncountable or infinite, you can use with these methods, chi-square and F distributions. In the confidence intervals, we learn or we take about the range our confidence. It should be in 90%, 95%, or 99% in the social science. But it could be different in maybe in the pharmacy or in the health science. In the health science, we need to consider a very, very tight. We need to make a 99 maybe for the 999%. So it's very, very tiny of the mistakes, a very least of the mistakes, because it's depend on with the human life. Maybe we cannot make some error with the human life because it's cannot be resolved again. If you die, you cannot live again. So we need to make a very precise about the calculations. It's not about the social science, but it's the medical or health science is very different. So this one is only applied for the social science. Okay. This is a like I said before, if you have the confidence level of 90%, it means that you need or you have the error of 10% or 0.1. You can learn about the manual proportions like here, but I think this is for the basic concept, it's okay. But for the modern of calculations, if let's say that you are using Microsoft Excel maybe or SPSS, you doesn't need to learn about this formula. The computer or the software is automatically calculate with your data. Next, we have the standard deviation of confidence interval. We call about the chi-square distributions because this is not a symmetric functions, and sometimes we doesn't know about the number of populations or infinite populations, and then we need to creating about the freedom parameters or degree of freedom parameter. What is the degree of freedom parameter? This is talking about our considerations, our concern about the parameters, the number of variables that should be observed and affixed. It cannot be taken down for our formula. So it could be one parameter, two parameter, but it's no more than two, maybe. It's almost two or one. It's a difference with the difference case, but there is a little bit of consideration about the freedom parameters. And then for the application of the business, sometimes we need using the independent sample or paired sample. What is the difference of independent sample and paired sample? It's independent sample is talk about with the difference of samples. Let's see that I will compare the midterm score between Norlin and Diane. That is the independent sample because you are different. Okay, the paired sample is the paired sample is like this. If you have an examinations between Norlin and Diane, maybe it the first examination and the second examinations, we need to compare about the rising value of your score, like the first examination and your second examination between Norlin and Diane. That is the paired sample because I have the paired sample for Norlin for the first exam and the second exam, and another paired sample for the Diane for the first exam and the second exams. That's the difference between the independent samples and paired samples. Okay. If you don't know about the score, you can make assumptions like the variance is maybe equal or unequal, but it's only with the assumptions, not in a real case. So we need to make some estimations. It could be equal or not in a statistical. Okay. I think we should make some information. Nah, like this one. Sorry. Where is the baseball? Baseball salaries. Okay. In your screen is a baseball salaries? Okay, baseball salaries.
Yes, sir.
In here, maybe I will to show you about how to calculate in this one. In our Excels, or maybe you have a file, Microsoft Excels, you can find in the tab of data, and you can find about the data analysis. This one, if you can make data for the paired samples, is maybe you have the paired data and the samples about the assuming that you have equal variance or unequal variance. So, and also we have the another information like this one. Let's see that we learn about the to paired sample of the means. Let's say that we have the data from maybe for the center field. Let's say that we have the egg data for here and this one egg data in here, and I could be a label here, and let's say that we have the 5% of correction error, and the output is here. Okay, so we have the okay. In these results, we learn about the data, but we have the kind of the observation. 7 observation of center field and design hits. This one is let's make an assumption that this is a paired data. It's a paired data. We have the same people with the different positions. Maybe Norlin as a center field. This is your average of your salaries. And if you change about your position like to be hitter, the salary is different. So, but this is with the paired samples or with the equals data, and we can see about the correlations, about the statisticals and the critical statistic in here. So in this Excel, you can find about the any of analysis tools in here. Maybe you can make some ANOVA, maybe in for the next meetings. And we also have with the paired sample or the if you think about your data is having equal variance, you can use this one. You can sort with the variable 1, variable 2, and the difference. Or maybe if you believe that you have unequal variance, you can use this one. So it's similar, and you can very easy for making some analysis data. But at the first time, you need to activate your data analysis or analysis tools in your Microsoft Excel. It's very simple or very easy. In my Excels, only activate analysis tool packs without solver. But if you are using these solvers, you can analyze in here. Okay, that is the information about how to calculate or how to take an action in your Microsoft Excel. So next we will learn about the hypothetical testings or the hypothesis. The hypothesis is mean that we have the data and we prove the data, and also we have the answer of your data. What is the difference? What is the effect? You know about the data, you know about the answers, but it's still to be tested by the statistical data. So that's called about the research hypothesis. And if to be to answering about the research hypothesis, you need to make a null hypothesis. That is the hypothesis when your data is in the normal conditions. No no factors, no alternative factors, no considerations, no pressure about your data, and thinking about in the general of conditions about your data. The null hypothesis is should be testing with the alternative hypothesis. Like maybe you can pass or you can have maybe in the exams the null hypothesis if you coming to with your examinations you will pass. That is the null hypothesis. But the alternative is you can also have a fail of examinations, pass or fail. That is the null hypothesis and alternative hypothesis. So to creating about the tail of the test examinations, we need to know about your situations. If you learn about the effect is could be difference, maybe over, under, or the positive or the negative, you can use with the one tail of alternative. What is the difference between one tail and two tail? Two tail is using when you doesn't know about the sign of your test. Maybe what is the effect you doesn't know about it could be positive or could be negative. That's the function of the two-tail alternative. But if you know that if you coming for test, your score will be high or maybe will be down. That is, you need to make some alternative with the one tail of hypothesis. So it's depend on your answers. If you know the answers using the one tail, that is very very concerns than the two-tail alternative when you don't know about the signs or with the predictions. Sometimes as a research statistician, we make a error. What is the kind of error? The type 1 error is talking about if you reject a null hypothesis that is true. So you reject the true answer. That is the type 1 error. Okay. But the type 2 error is maybe more fatal because you accept the hypothesis that could be false. Yeah. So the between the type 1 at the time and the type 2, it's very fatal, it's a type 2. You can reject about your good answers. That is okay, no problems. But if you accept the false answer or the false hypothesis, that can you make a type 2 error. So we need to know about which error that you make in your data. Sometimes we make a type 1 and sometimes we make a type 2. But it could be happen if you make a research. Okay. How to confirms that we have to accept or reject our data or our decisions. We have the rejection of region in a statistically, not in literally. And statistically, we base on the number, the percentage, the number that like your error or the probability of your error. Let's say that we have the probability of 1% or maybe 10% that if your data is below of the rejections that we need that's the alternative that we need to accept your hypothesis. But if your error is over than your rejection region, that is the mean that you need to reject our hypothesis. So the significance is means that we have it can be measured by the p-value, or sometimes it could be measured by the t-value, but it's similar, but the number is different. The t-value is higher than the p-value because the p-value is between 0 and 1. It's coverage for 100% or between the 0 and 1, but the t-value is between the number 1 into an infinite. So it could be 2, 3, 4, and 5 and over them. That is the power of the hypothetical testing. Let's say that we learn about the data in the baseball salaries. Yeah. Okay. The baseball salaries, we have the t statistics, and this one is the p-value. If you have, so if you have the 5%, if the 5%, this one is 40%. So we can reject the hypothetical that the hypothetical is between the center fielder and hitter. The fielder and hitter is having the same salary. If you find about the p-value is 40% is over than 5%, we need to reject these assumptions. So we cannot accept that the salary of fielder and hitter is equal, is same. So for the number, it's a real difference. It's 7 million and 8 million. So for the number is difference. That's okay. But the statistically is difference. You can use this one, or you can use with the t statistics. The statistic is between 1 to over 10, but if the p-value is between 0 to 1, so there is no more than 1. Like this one is a t critical is over than 1, 1.9. This one is 2.4. But if we talk about the p-value, like here, p-value, and this one is also p-value, is between 0 to 1, or between 0% to 100%. Yeah. So it should be 0 0.0, not in over than 1. Yeah. You can learn about the T or P, but in familiar, I think in the general of statistician is rather using p-value, because the number is very simple between 0 and 1. Okay. That is the how to the practical how to we make some decisions using the statistical significance, using p-value and the t-value. T-value is labels like here, and this is the formula, and this is hypothesis for the population means. But the p-value is for the sample of our means. For the equality, we have the difference formula, but in the Excels or in the formula of our statistical is only with the difference point of the analysis, like here. So when you open your data analysis, like here, the difference is only creating with your choose. You assuming you have equal variance or equal variance, and then click OK. No more than formula like this here. This one is for a manual calculations. In a statistical class, maybe you will learn about the manual calculations, but in this class, I think we need to know how to analyze data with a simple ways or the simple methods using the application or using the software. Okay. Ensuring about the data that should be normal. We have the normal distributions that maybe it's containing about the statistical procedure is could be happen in under the normal distributions. It means that you are allowing to test your data, because the normal, it means that you have the similar of mean and median. Refer to the last meetings, mean and median. If you have the similar value of mean and median, it means that your data is distributed in a normal conditions. Okay. To test about your independence of your data, you can use about the chi-square, but sometimes we need to we can ignore this independent test, because in the data analytics we are not categorize the independence of test, because the independent of test is only for separate the data between the data 1 and the data 2, but in here we only taken the data for the public data or the popular data. It should be independence. It could be in different resources. Okay, I think that's all that we need to learn about the inference of statistical data analytics. Any questions so far for Norlin and Diane? Any questions, Norlin or Diane?
None so far, sir.
Okay.
None, sir.
Okay, thank you for responding me. I will let me stop